Hi, Sebastian. Hi, Oleg. Welcome to Joker.
Hello,
Hey.
hello.
Yeah, Oleg, as an expert today, would you help me to introduce Sebastian and his talk, please?
Sure, absolutely. Good morning, everyone, or probably good afternoon. And welcome to this presentation, to this really hot topic, because we will be talking about Graal Native, native images, and Spring. That's amazing. I love Spring, and I'm looking forward to more cloud native application. So Sebastian will be talking about that. And a little bit about Sebastian. Sebastian is a really great person. I knew him as initially as a contributor to Spring and Kotlin. So he did a lot of things related to great Spring integration with Kotlin. He's done a lot of integration in Reactor, and I'm talking about Reactor because Reactor is my passion. So I knew Sebastian from that side, but now Sebastian is heavily focusing on integration with Graal Native, on building kind of really cloud native Spring application with Graal support. So Sebastian, please talk a little bit about this topic. Please introduce a little bit more about yourself and talk and tell what we will be doing today.
Thanks a lot for the introduction. So yeah, I'm Sébastien Deleuze. Like you said, I'm working on Spring, so I'm more specifically a Spring framework committer. Like you said, I have worked a lot on the Kotlin integration, and now since our Kotlin integration is pretty complete, I'm moving most of my activity on working on native application, GraalVM native support, and that's what we are going to talk about today. So a quick safe harbor statement, so that's just a regular warning that what I'm going to present will change because that's all R&D work. And today we are going to start talking a little bit about native executables and GraalVM. We will then talk about Spring Native. We will explain how you should get started working with this native thing with Spring Boot. I will do a quick demo, and we will talk about the roadmap. So let's talk about native executables. So GraalVM is a project started several years ago by Oracle. It allows, among other things, to compile Java or Kotlin application or any GVM-based application to a native executable that does not require a GVM, no Java virtual machine needed to run the application. It's done via the GraalVM native image compiler, and the typical use case, at least for us, is to produce lightweight container images. GraalVM is a wide project. You can do a lot of other things. It allows to do cross-language in a much more better way. So here, today, we are really going to focus about GraalVM native image compiler, which is really the native support of GraalVM. So why should you do that? I think there are two main reasons. The first reason is to get instant startup. So instant startup allows to do new things compared to regular GVM. It allows to scale to zero because if your application is not used, you can basically shut down and avoid to pay the related cost of it. You can do basically serverless with for any kind of workload. So serverless is super interesting, but it requires to change the way you develop your application, and that's maybe something that you do not really want to do. So while native is super nice for serverless, it's allow basically to transform your regular web application in a kind of serverless runtime mode. And I think that's a pretty good fit with platform like Knative. So Knative is a Kubernetes-based platform that basically is really designed to pop up containers as soon as you get a workload that come via typically an HTTP request. The other use case, I think, and the other interesting point is to have reduced memory consumption. Now everybody is on the cloud, and what you pay is related to the size of the instance that you get on the cloud. And being able to reduce the memory by 4x ratio for small or medium-sized application is pretty interesting, especially when you split your Java or Kotlin microservices into a lot of multiple microservices. And here, if you are using the GVM, you will pay basically a tax for each instance because all the GVM infra consumes some memory, especially for small application. So I think that's pretty interesting for basically getting cheaper and more sustainable Java applications. So those crazy new things are pretty interesting, but GVM and Native are about different trade-offs. And I'm not here to say Native will replace everything. It's just providing a new deployment option with different characteristics. So while Native shine in terms of startup time and memory footprint, it has a slightly lower latency throughput if you have unlimited resources in terms of CPU and memory. The maturity is not the one that the GVM has, but it's increasing and improving quite quickly. So I expect that part to be improved quite significantly next year. The main drawback that will remain, I think, is longer build time. So we will see that concretely with figures later. So in terms of CPU and memory profile, if we compare the famous Spring pet clinic sample between GVM and Native, at the left you can see the GVM. Excuse me, I have flipped. So the Native is at the left. So basically, you can see that you have instant startup, and you have lower memory footprint, while at the right in the GVM side, you have longer startup time and more memory consumption. In terms of performance versus instance size, you can see that where you have more resources, like at the left, 1 GB of memory and 4 CPUs, basically GVM is faster. Lower latency means higher performance, where for the native variant, if you have something like 128 megabytes of memory, so very low memory for Java workload, and just one logical CPU, you see that the native version is much more stable and provide a much more better latency than the GVM. So it's all about optimizing the runtime cost of your application and choosing smaller instances on the cloud. So let's take a moment to talk about the key differences between GVM and Native. So because that's pretty important to understand. So with Native, when you do the native compilation that happen after your regular GVM application, because basically what the native compilation take as input is your Java bytecode, you are going to do a static analysis of your application from the main entry points, and everything not used will basically will be removed. So what you are going to have in your application is only what is explicitly used. That's why explicit configuration is required for reflection, proxies, and resources. You have also the class path, which is fixed at build time. No class lazy loading, so that's pretty important. In the GVM, a class is loaded when it is used. In Native, you need to determine that at build time. So basically, everything, you need to optimize things before compilation at build time, before everything chipped into the native image in terms of resources or classes will be loaded at memory at startup. And last point, you have optional build time class initialization. So that's something that is interesting in terms of optimization, but we should be careful to not go too far with that, because it can impact significantly the maintainability. I think GraalVM Native is a source of inspiration for the whole GVM ecosystem. And we see a native support coming into various libraries and frameworks, and we see also that the GVM ecosystem as a whole is currently adapting to this new way of running application. And this kind of native ahead-of-time compilation is also an upcoming standard with the project Leyden, which has been recently announced by Oracle. So I guess we will talk more about Project Leyden later, but that's a kind of standardization of native in the Java platform. It's not exactly what GraalVM is, but basically that's significant because the Java platform will standardize a kind of native support, and I think that's pretty important for the long-term future of this native support. So let's talk about Spring Native a little bit. So Spring Native is basically the support for compiling Spring applications to native executables unchanged. So we don't want you to have to change your current Spring Boot application in order to support this platform. The Spring team is doing the hard work, and when that will be finished, you should be able to run your existing application without more change than updating your build, basically. So this support incubates in Spring Native for GraalVM, which currently incubates in this project. So you see it lives in Spring Project Experimental, and you can have a look. Everything is open source. You can follow our progress, and that's it. There has been a collaboration between Spring and GraalVM teams, a pretty great collaboration. Here is a quote for Thomas Wöswinger, who said, "We are excited about the great partnership between the Spring and GraalVM engineering teams to support native ahead-of-time compilation for millions of Spring Boot applications. This is a game changer, enabling low memory footprint and instant startup for these workloads." And I would like to thank Thomas and the whole GraalVM team. We have been collaborating quite efficiently these last few months, and we plan to continue and increase this collaboration. You can see on the GraalVM project, if you go to GitHub and you check, there is a Spring label that will allow you to check the current GraalVM issues related to Spring. So typically issue that we raise because we face that when we run Spring applications. And you will see a lot are closed, some others are open, and we continue to collaborate with the GraalVM team in order to close the gap and make sure that GraalVM is a good fit to run Spring applications. So the question is concretely, how will you leverage this native support? We are basically leveraging the Spring Boot container image support. So you may be aware that as of Spring Boot 2.3, you can create container images natively with Spring Boot by running Spring MVN Spring Boot build image or Gradle boot build image. And that will build a container image using cloud native build packs, also called Paketo build packs. And we are going to use this mechanism to build a container that does not contain anymore the Gvm and your bytecode, but a container, a more lightweight container that will contain only the native executable that will be compiled from your Spring Boot application. So in terms of timeline, we are working on supporting GraalVM for almost 2 years now, I think. The beginning of our work was really focused on fixing GraalVM itself, because at the beginning we were only able to run very minimal Spring applications, and Spring is using a lot of the GDK, and GraalVM is basically a new flavor of the GDK, and they had to do some fixes to support what we do. Obviously, GraalVM is a kind of different beast, so it won't support everything that the GVM supports. But I think there was some missing bits, and the collaboration we had with the GraalVM team. And now I think most of the critical bugs are fixed in terms of compatibility, and we are more collaborating on other topics like testing, improving the footprint, etc. But I will share more about that later. At some point, when we have reached a point where GraalVM was mature enough to compile Spring application, we have created this Spring Native for GraalVM incubator, and the purpose is really to mature our native support, because that's quite a long journey. GraalVM Native is pretty young, and also we need to take the time to mature it. Also, the GVM ecosystem needs to properly support it, and that's not super easy because testing is not that great currently, and that's basically a different flavor of Java. Also, we are collaborating with the GraalVM team to limit the difference of behavior between the regular GVM and the GraalVM flavor. And the next step, and that's a pretty big one, is first-class support in Spring Boot 3. And basically, everything we do with Spring Native for GraalVM is designed to fit in Spring Boot 3, Spring Framework 6, and related other Spring release. We don't intend to make a Spring Native for GraalVM top-level project in Spring. We basically plan to incubate support this year and next year, and then it should all go to the regular top-level project that you already know: Spring Boot, Spring Framework, Spring Data, Spring Security. So yeah, go to the project. You can follow our work. So this project is really an incubator for Spring Native. It analyzes the Spring application at build time. So basically, it will compute the most optimal native image configuration. Remember, previously I was mentioning that you can compile basic Hello World with GraalVM without any kind of support, but as soon as you start to use real libraries like Spring itself, but also all the libraries that you will use, Jackson, Hibernate, Teamleaf, everything like that, typically they are using reflection. They are using, basically, you need to specify what are the resources you need to include. And if they use proxy, you need to configure that. And there is also the class initialization that need to be configured. So if we do nothing, you should have to configure everything manually, which would be a showstopper because basically too much work. It's just not maintainable. So basically our Spring Native support is basically computing automatically based on our knowledge of the Spring infrastructure, ecosystem, and of your application, configuring everything automatically in order to get automatic support out of the box. And the challenge is that typically we decide a lot of things at runtime. And here with the GraalVM static analysis, we need to move some things that are done that were done at runtime at build time for native at least. So basically, reflection is fine with GraalVM. You just have to do it at build time. It's not about removing reflection. It's just that the reflection will be done at build time, and will basically provide some configuration in order to make your application run perfectly at runtime with a small footprint and with a good level of compatibility. So in order to achieve that, we are going to perform some build time transformation in order to have optimized footprint and better compatibility. So we have just released 0.8.3. So you can use it right now. It's based on Spring Boot 2.4.0 and GraalVM 20.3.0. An interesting new features that we have is that we don't require anymore to have proxy beans method equal false on Spring Boot application and add configuration. So that's typically the things that we are going to do. There is currently some constraint in terms of what starter you can use, in terms of this kind of small differences between native and the GVM. And we are going basically to remove those differences in order to get you in a situation where you can run your Spring Boot application out of the box with this new platform. Okay, we have introduced some new flags available in Spring Framework 5.3. So you can see that we have the Spring XML in your equals true flag that basically allow us to remove at build time the XML infrastructure, and we have also the Spring spill in your equals true, which allow to remove Spring expression language at build time if it's not used. So currently you have to set those flags manually at build time. And what we intend to do is basically to analyze your application via build time transformation. And if it is not using XML or spill, those flags will be set automatically, allowing build time code removal and optimized footprint. So that's an ongoing process, and currently you have to set it manually, but that will be automatic. Our work is really not focused only on Spring. In fact, we are collaborating with the GraalVM team and the community to make the Gvm ecosystem a better place for native. So, for example, since we are involved in Tomcat development, we are working on an experimental Tomcat embeds programmatic artifact, because basically Tomcat is using reflection in a lot of places, and reflection support is possible with GraalVM, but it leads to bigger footprint if you do the reflection at runtime. So here there is two possibilities. Like I said previously, you can move the reflection at build time, but you can also basically transform your library in order to use functional and programmatic construct, and that's exactly what this is doing with Tomcat. And those programmatic constructs will be natively understood by the native image compiler, and that will lead to basically less native configuration, smaller footprints. And that's why basically functional programming, lambdas, etc., are a good fit with this native platform. We check automatically basically our support and the various samples that we have with our CI in order to provide fast feedback to the GraalVM team when something breaks on master, for example. So we typically build against the latest stable version. So here it's 20.3. And we are also building against the development version, which is 21.0 currently. So concretely, if you want to start supporting native for your application, what should you do? So you go to start.spring.io or on an existing project. Currently, we have not reached yet the beta status, so I would advise you to just play with the samples, or maybe try that on a simple web application. So let's say you go to start.spring.io, and by default, the Spring Boot Maven plugin is generated, or if you are using the Gradle one, it's the same. And what you will have to do in order to support native is basically to configure the image part in order to specify that you want to use native image like that. Obviously, later you will have dedicated options, but right now, since it's experimental, you are using environment variable like that. You have the same for Gradle available, and that will basically create a container using a native executable instead of your GVM, typically your GVM application. And what is interesting is that the build itself happens also in a container. You will also have to add the latest Spring GraalVM Native dependency. So that's typically our native support. If you don't specify it, the latest will be taken in account, but I advise you to basically define it, because a certain release of Spring GraalVM Native is really tied to a certain release of Spring Boot, so better to specify version explicitly. And then you build it with Maven Spring Boot build image. Like I said previously, and I will show that in the demo, the build can take times. In fact, in the demo, I will use some catch, so you won't see that, but the build will typically take more times. That's why I expect it to happen typically on the CI/CD platform rather than on your local machine in terms of regular development. So if you had the temptation to think that GraalVM is about super fast local development, sorry, but that's totally not the case. GraalVM native images are, to me, an optimization for efficient run and deployment as a container on the cloud, not something that will lead to faster development loop, because the instant startup as a drawback is that you have a very long build time. And that's the same for every GraalVM native image. So with our support, there is no need for a GraalVM native local install. Everything happens in a container. It will basically use automatically download the GraalVM native image compiler, bundle it into a container, make the build, and produce a container. And then you run it with your regular platform. Here, I'm just using a simple Docker run, but you can run with what you want. You have just a regular container with a native image. But you can also build a native executable without using containers. So you can configure a Maven plugin in the native profile. So this is the native image Maven plugin provided by the GraalVM team. You will run that, so typical clean package. and then it will run. You will have basically directly the native executable available. Be aware, there is no cross compilation. So if you are on Linux, you will compile a Linux executable. So now a quick demo. So I just want to show you, this is a regular Spring Spring application. So basically, if you have a look to the application, you see that's a regular Spring Boot application. You can see that with the controller, it's an annotation-based controller, okay? And if I go to see the POM, this is a regular Spring Boot 2.4.0 application. And the only thing I did here is specify that I want to use a teeny image. I'm going to show you more about that later. I'm going to say I want a native image, and here I'm specifying the arguments that will be later specified automatically. But otherwise, that's all it costs. And then I'm going to build with Maven Spring Boot build image. So here, it's a regular build that creates your bytecode basically. And after the bytecode is produced, there is a native compilation that happens. It's using the build pack integration of Spring Boot, and that will create a container. So here, it's going pretty fast because I'm using a catch. I have done the compilation before, but I think that's okay for the demo. And now, if we check what is inside this container, I think we see interesting things. So here, I'm using a teeny based OS layer of less than 20 megabytes. So that's really a Ubuntu-based package composed of only 7 packages. So typically glibc, OpenSSL, and things like that. And on top of that, we put our application, which is close to 50 megabytes, and it's a JDK, the Spring Boot application, and your own code. And that leads to a pretty small image size. We are working on improving the size, so expect much smaller size as we progress next year. And if I want to run it with Docker, so here I have a small Docker compose, okay? And if I run it, you can see that it's starting pretty fast. Yeah, I can just go here and check my application. So we have also a lot of other samples available in Spring GraalVM Native. You can check pet clinic, etc. So a lot of other samples are available. We have also a Kotlin sample if you are developing with Kotlin. So feel free to have a look. So for pet clinic, for example, you can see that in terms of builds, we have a pretty impressive augmentation of the build time. That's why I said it's, I think, more a CI/CD thing in your real life use case. You can see also that we have a significant decrease of the memory, and pet clinic is a regular application. So it's interesting to see that we have a memory reduction pretty significant, 4-time memory reduction, and the startup time is very fast, and again, that will be even faster. So basically, I think with any kind of Spring application, you will get instant startup and also instant peak performance, because with native, you don't have to warm up everything. The peak performance is available immediately. Also, we are working on a lot of optimizing things. So since last year, we have done a lot of progress, and we continue to improve things. And with the upcoming build time transformation, you can expect a significant reduction of the footprint about what we have today, which is already pretty great. So let's talk about the road ahead and the roadmap. So if you go to the Spring GraalVM Native GitHub and you go to the milestones, you will check. We have an up-to-date roadmap. We are very transparent about how we move things. Everything is public. And today, we are working on the upcoming 0.9.0 release, which will be our beta. I will explain a little bit what that means. And we will have some 0.9.1, .2, .3, etc. And we don't expect 1.0. 1.0 will be Spring Boot 3, basically. So this 0.9.0 is planned to be released early 2021. I don't communicate specific dates. It may be, yeah, it will be beginning of the year. We will release it when it will be ready. And that will be the first release with a beta status, meaning that we think that the level of maturity is enough for you to try it with some small application. So we will support a subset of starters, so don't expect everything working directly with your big application that uses half of the Gvm ecosystem. That's really about, okay, a signal about you can start using it with your application for a try. It will be based on Spring Boot 2.4 and GraalVM 20.3. And breaking change will happen because we are going to do a lot of changes, but we will provide upgrade path. It will provide wider support, so Spring Security and Spring Batch will be supported with some limitation. And it will introduce a big change, which is the build time transformation that we are going to ship with Spring. And that will we will start by this free build time transformation, programmatic Spring factories. So Spring application comes with a spring.factories file, and we will transform that at build time into real code that GraalVM Native can analyze automatically. We will transform the GraalVM feature, which is a kind of GraalVM plugin we have currently, into a native configuration generator, and we will automatically configure what is in your SRC main resources. In the upcoming 0.9.x version that will be released next year, a very important point, we plan to switch at some point on Spring Framework 6 and Spring Boot 3 because basically we have done all the optimization we could with Spring Boot 2.x baseline. We even use substitution that are replacing partial place of the code of Spring Framework and Spring Boot and Spring Data by native optimized code, but that's not very maintainable. So at some point, if we want to provide you high quality support, we need the changes, architectural changes that we are currently doing in Spring Framework 6 and Spring Boot 3. So you can expect, that at some point we will switch on some milestone next year, I think. And GraalVM 21.x will be used. More build time transformation, testing, focus on maintainability, footprint, and build time reduction. So that's really our plan for next year. So this is the list of the build time transformation that we have planned. You have the list in the bug tracker. So you have this tag type build time transformation. So feel free to have a look on the various build time transformation that we plan to implement and that will be refined over the time. And one of the build time transformation we are going to do is to transform the add configuration programming model that is used by Spring Boot currently, and that's basically our basis for all the configuration in the Spring ecosystem, into functional configuration. So functional configuration is basically Lambda-based configuration that can be understood natively by the native image compiler. So the interesting point is that it's more maintainable and it's provide smaller footprints. And that's the topic I have typically experimented on in Spring Foo, if you know this project. So, and Dev Sire has created this Spring Init project, which is basically an automated converter from add configuration to functional configuration. Again, we don't require you to change your programming model. It's our work to do the hard work, the hard changes, to be able to support that easily for you. And with this automated transformation from add configuration to functional configuration, we see a very significant decrease of the footprint and an improved maintainability. Hence, our goal to do that in the upcoming milestone of Spring GraalVM Native. So Spring Boot 3 based on Spring Framework 6 is expected to provide first-class support for native application deployment. And I think another important point is that it will provide an optimized footprint on the Gvm as well, because some of the build time transformation we are going to do may be useful for the Gvm as well. So our work is really focused on providing the best experience possible for Spring application on this native platform. We are developing the build time transformation in that spirit, and we may choose some, I think, optional build time transformation because we don't want to make that mandatory. But some build time transformation could be also useful to have an even more optimized footprint on the GVM, and it may be available in the later version of Spring Boot and Spring Framework. So a few takeaways. Spring Native is great to build lightweight containers. I think that's really really our focus here. Like I said, it's more a CI/CD thing. I think so. Our work is really to get support mature enough in order to make it possible to compile that on the CI/CD. Obviously, you will have to check that your application is running fine. You will have to test that, have automated tests. But since the artifact that you are creating is really tied to a certain platform, because that's containers, because that's native executables, I think that's really up to the CI/CD platform to create that, because I mean, we are talking about ARM support these days. And if you create native container that is designed to run on x86 locally, and that your workload is on another platform, that will not play well. But that's super interesting for optimizing the costs, making Spring application more sustainable. And yeah, I think that's pretty exciting platform. You can try it now with the Spring GraalVM Native artifact with the 0.8.3 version. We will take some time, like I said, to work on this 0.9 beta release that will happen in 2021. So we will publish really a list of starters that will be supported and of the limitation, because obviously we need to mature this support, and it will not support everything at the beginning. But I think in terms of roadmap, we are pretty clear about where we want to go, how we want to achieve our goal in terms of compatibility and native. And it's not about only consuming GraalVM, it's also about collaborating with the GraalVM team and with the Gvm ecosystem to make GraalVM native maintainable. Because I think the biggest challenge of GraalVM native, okay, it's exciting, it starts fast, it's it allows to create optimized container, that's perfectly fine. But I think the main challenge is about keeping those characteristics and improving the maintainability, the testability, and everything like that, because that's something that needs really to be improved. And that's why we collaborate on this topic. On testing, we are collaborating with the GraalVM team, and we will share more about our testing support early next year. We plan to collaborate with the GVM ecosystem, and if there are some people here from the GVM community, supporting the GraalVM currently is pretty hard for libraries, because testing is bad, and usually maintainers of the libraries have not yet GraalVM native knowledge. So basically, they get some pull requests with some native configuration that they can't really test, and that's why it's quite fragile sometimes. But at the same time, we really believe that it's up to the libraries to support this native platform. So the GraalVM team is working on limiting the differences of behavior between Gvm and native in order to avoid to have two different flavors of Java to support. And the work on testability and helping the community to support native at library level, it's key, and we plan to work a lot on that. And in order to get support for Spring, we really want to collaborate with the community to get native support at library level. And yeah, we plan upcoming first-class native support in Spring Boot 3 Framework 6. No date to share yet. And if you want to contribute with feedbacks, or if you want to contribute support for your favorite starter, we provide a documentation in order to explain you how you can add support. Currently, it's really done at Spring Boot level, but basically we are working to basically bring back the native support at Spring Framework, Spring Data, Spring Security, and less at Spring Boot level. So that's an ongoing process. Thank you for attending. I guess we are going shortly to discuss about various questions, but here I share one more time the URL of the Spring GraalVM Native project. You can follow, I will share various blog posts about native in spring.io/blog. And you can follow me on Deleuze if you want to have more fresh news about Spring Native. Thanks.
All right, that was awesome. And that gave us a lot of insights about Spring integration with Graal Native, about some bits of Graal Native and their progress on like building their stuff for community and for project maintainers, framework maintainers, and so forth and so on. And of course, we learned what is the current state of a Spring framework, where it goes with integration with Graal Native, etc., etc. So thank you, Sebastian. That was really cool. That's really interesting topic in the light of what's going on in the world nowadays and in other frameworks. And I really hope that in the closest period of time, in the closest year, we will get really fast Spring framework with really small startup and the really small footprint of memory. So thank you. And I have a couple of questions from community and from my side. So if you don't mind, I'm going to ask them.
Sure.
All right. So the first one will be from community folks, like from the attendees of this talk. And what I got is, as an alternative to GraalVM, is there any benefits to run Java out of like ahead of time compiler, GAOTC, on the same Spring classes? Did you think that precompiling Spring classes as native libraries and distributed it, does it have any benefits to do so?
We have done some experiment on various things like that, also checkpoint in order to start the GVM faster, etc. I think in terms of AOT, there has been recently some changes on OpenJDK to remove some AOT related things because the benefits were not enough, and that's what we have observed. And we prefer, I think, to bet more on this native image thing, because that really provides significant benefits. Why with what we tried with Spring workload or with other, the benefits were not enough, and what we see in terms of transformation in OpenJDK and changes is going into the same direction. So I think we prefer something that provide more benefits.
Yeah, that makes sense. I mean, I heard you say briefly about Project Leyden. So I believe that this is the direction where JDK is moving nowadays. So can you comment a little bit about Project Leyden? I'm curious. So you're focusing today on GraalVM stuff, and you're trying to build pretty good integration with this JDK with GraalVM flavors, as you say. So I'm wondering, won't be that like this big breaking changes once Project Leyden comes to the rescue and provides its own API and standardize many things related to this closed world native compilation. So what do you foresee in that integration?
Yeah, so that's a very interesting point, and that's why we are gradually refactoring our project into a Spring Native support, and Spring Native support for GraalVM, but also for Project Leyden. Obviously, that's really the early days of Project Leyden, and we have a very few informations about it. So it will go at its pace, and we don't wait for it for having native support. But we really want to be able to support it easily. And in fact, our Spring Native work, there is some parts that are really specific to GraalVM, but they are going to be isolated into a dedicated layer. And most of the changes that we are going to do may be partially useful on the GVM as well. So it's not just about native. It's really about basically being useful maybe on the GVM, having a dedicated layer specific to GraalVM Native. But we try to make this layer the smaller possible. One example is that currently we have some GraalVM native reflection configuration for Spring factories, for add configuration, etc. So we maintain this instance, and that's not really easy. Like I said, the main challenge of GraalVM native is the maintainability for everybody, for the whole ecosystem, I think. And we plan to just avoid to configure anything by transforming the Spring factories, which are property-based thing with some classes specified here, into a programmatic version. So basically, we plan to generate some code that will basically use Spring functional bin registration or programmatic constructs based on lambdas to register things, and that will be natively compatible with GraalVM Native, and we expect it to be natively compatible with Project Leyden, which will be similar. So our work is really to lower the amount of GraalVM native configuration using this build time transformation, and all the work that we have been doing for more than 5 years now on functional bin registration, because all these things are leveraging something that we have been maturating via Spring Init, Spring Foo, and Spring Framework 5 support for bin registration, functional bin registration. And we will have a proper layer, hopefully the smallest possible, in order to support it. And I think that's the same for the GVM ecosystem. We would like to, and we collaborate with the GraalVM team in some ways of configuring libraries in order to support native. And we would like to make sure that will be relevant for Leyden and GraalVM for both.
Yeah, thank you for your answer. I mean, in general, to me, it sounds like, hey, this is JDK team at Oracle, and they decided to do their stuff, and here is GraalVM team that has already done everything that basically we need, and now they're trying to compete. But yeah, let's hope that this competition will end up with something great. All right, let's move to the next question. So again, one question from my side. I mean, I'm Spring developer, and I've been on that side for many years. And I've built really different applications. Today, I'm focusing on reactive stuff. And of course, we have like Spring Webflex, RSocket, and many other cool things on reactive side. But there is like a huge number of folks who are doing the same old good enterprise things with Hibernate, with all these heavy frameworks with which you can easily build your application using Spring, of course. So I'm wondering, what is the state for them? I noticed that there is some support for some plugins in Graal native, Spring Graal native plugin. So I'm wondering, what is the state of this part? What plugins, what integration, and what dependencies do we support today, and what is the future for that?
Yeah, super interesting point as well. So it is interesting to notice that the Spring Data is very much involved in the native support. We have Christophe from the Spring Data team that is working a lot on our native support, and we currently have support for Spring Data, so incubating support for Spring Data GPA based on Hibernate, on Spring Data JDBC, Redis, Elasticsearch, Neo4j, etc. So we are improving our support. Obviously, the GPA support is the most challenging because GPA and Hibernate are big piece of technology and maybe not natively very perfect fit with native. Obviously, we work on support for it. We are not sure how much. We have not started to optimize the footprint, for example. So we really want to get the basics working fine on Spring level at the configuration. We leverage some plugins provided by Hibernate to basically do the bytecode generation at build time. So like usual, it's about moving runtime process to build time. And that works currently. So I think the optimization and the work that we need to do is maturing this support and make it more efficient, because in terms of footprint, it leads to bigger images. So in terms of build time, and that's also usually used with transactions, etc., with the at transaction annotation. And that's where we have some plan to create proxies at build time, at least to experiment on that. And that will be available during next year. So we need to evolve our support to have all the related pieces to finally get to the point where we work on optimizing Hibernate footprint and things like that. But yeah, like I said, the Spring Data team has a huge focus on native and efficiency. They are working a lot on various things that will be shared next year about that. So you can expect a good level of support, and we will work hard on that to provide high quality support for most of the Spring Data portfolio, including the GPA side. But yeah, too early to say where we will land because there is a lot of ongoing changes. So yeah, basically currently you have support, even if it leads to bigger footprint.
Yeah, I got it. That's great. By the way, I got like subsequent questions which just born out from your discussion, from what you said. Do you know any movements on the Hibernate and GPA community side? I mean, because like there is Spring framework and there is other communities. So I'm wondering, are you aware if those folks are doing something in order to support Graal native images?
There is an artifact, a dedicated artifact in Hibernate for getting support for native. It does not configure everything, but it kind of help. But I think the current blocking point is that with the native configuration based on JSON or the features that GraalVM Native provide, you can't really achieve an optimal footprint and an optimal compatibility if you just ship the support at library level, because basically you need to be at the framework level, so here Spring, in order to do more optimization about how it is used, etc. So with the current native configuration capabilities, it's kind of suboptimal, and I think that's a blocking point, and that's where we would like to collaborate with the GraalVM team and the ecosystem to provide more optimal ways of configuring GVM libraries in order to get the best of the two worlds. You get the native support and at the library level, and the library is able to test native image easily, because currently that's quite a hard journey. You also, basically your library is responsible for providing and fixing bugs on that support. And at the same time, you provide the way of configuring native support in an efficient way, because currently, for some simple use case, that's okay, but for bigger use case, you have to use a lot build time, class initialization, which is not really maintainable in the long run, or you have to be at the framework level and do a lot of funky, not maintainable things, and that's not what we want to do.
Yeah, that's obvious. So having that, I'm wondering, okay, so it sounds like in general you got into good shape with this Graal native integration. Not perfect, but I'm wondering what is the level of maturity, how production ready is what we have right now, and having that in mind, what do you recommend in terms of for like average developers? What would you recommend from the Spring Stack perspective to work on? Because we have, like, again, this old good enterprise Spring MVC and Hibernate and GPA and other libraries, and at the same time we have this fancy cool new reactive part of Spring framework. So what would you recommend to focus more if one wanna build like a cloud native application with really the scale zero capability and Graal native image support?
Mm-hmm. Yeah, so that's a good point. That's true that we have our regular stack that is the most used, the most widely used, with Spring MVC, Tomcat, etc., and the reactive one, which is that you know pretty well. I think so. We support both. So currently we have, if you check the samples, we have WebMVC and WebFlux samples support. We intend to provide the same level of support for both. So I don't think the stack should be a reason to there is not a better stack for native. I personally put quite a lot of focus on the Spring MVC stack because this is the most widely used, and we really want to provide a first-class support for what people are using the most. Also, there is Project Loom that may come later, so it could maybe improve the scalability, even it will not provide an asynchronous programming model and the reactive capabilities that our reactive stack is providing. But really, we want to provide both, and we don't want to favor one stack over the other, just good support. And since there has been some work on the native side already for native, but not on Tomcat side, and since we are involved in both, we put a little bit more effort in making Tomcat native compliant with this programmatic embedded artifact, because there is more work to do, and that's why we try to contribute where that makes sense, basically.
Yeah, that's perfectly makes sense. But yeah, this is one part, but we got used to some, like, configuration style and so forth and so on. And you've been already talking a lot about another great feature, great new kit of Spring ecosystem, which is Spring Foo. So how Spring Foo will help with the development of this Graal native applications? Is it gonna help anyhow to reduce memory footprint and produce lighter applications and so forth and so on? So can you comment something about that?
Yeah, sure. So I have created the Spring Foo project. So Spring Foo is about providing DSLs. So some kind of expressive API to configure Spring Boot in an expressive way and in a programmatic way. It's available on Java with Jafoo and on Kotlin with Kofoo. Kofoo being the more pleasant to use because Kotlin provides some DSL capabilities, but we provide the same scope on both. And this one is really super. It's really experimental. We don't expect to be production ready on Spring Foo for now, but it's evolved and we get more contributors, and it's moving quite great. But there is two parts in Spring Foo. There is configure Spring Boot with a functional DSL. So that part is still incubating, but all the work that has been done on the functional configuration has helped us a lot in this native topic, because DevSire has created this Spring Init project, which is automated conversion of add configuration to functional configuration. And what we plan to do is to integrate the work that has been done on Spring Init and integrate into the Spring Native support, at least partially. And it will change a lot. We will be heavily refactoring, but and our goal is really to not require you to change your programming model to get the benefits of those efficiency improvements. And that's true on native, but that's true also in the GVM. So what we are working on is introducing a set of build time transformation that will make your regular annotation-based programming model closer to functional. I don't say that will be exactly the same. Spring Foo will keep an advantage in terms of footprint. There will be also less build time transformation because your application will be almost natively native compatible. In our current support, we have almost no configuration, no reflection configuration. Your application, if it is written with Spring Foo, it is natively compatible with GraalVM Native out of the box. So that's pretty amazing. That's pretty optimized, and you get the most optimal way. But with the build time transformation that we are going to do, and that will be a long journey. I mean, we are going to do that first at configuration level and maybe later in other places. You are going closer to the functional mode. And that way you can choose your programming model based on how do I want to write my application? Do I prefer annotation, Spring Boot conventions, and what is used by a lot of the vast majority of Java developers in the world? Or do I prefer more functional programmatic constructs where everything is specified explicitly. I don't want a behavior change because I have something in my class path. And that should remain a choice based on what programming model do you use and you prefer. Optimal performance should be provided by both. And obviously, that's much more work for us as the Spring team to provide this level of performance based on the annotation-based programming model, but that's what we are working on. Very hard.
Yeah, that's great. I mean, from my side, I mean, I started using this new reactive stuff, and I started using this new router that Spring Web Flux offers to the users in order to configure all the routes, and it's just simple, straightforward in a single place, so you don't have to look over millions of classes in order to find your controller and handler. So from my perspective, this movement is something really great, and I don't see any problem to configure your not that big microservices explicitly using functional programming style. So yeah, it's a great thing from my point of view, and great job. Yeah.
And something I can add about that is that so we are working on in parallel in making functional Spring even more compelling and more widely used. So Ariane Putzma has recently joined the Spring Foo team. So now Spring Foo team, we are 4. We have Audrey Neveu, we have François from Elastic, we have Ariane Putzma, because Ariane Putzma, that's a pretty big point because Ariane is from the Spring Framework team. He has created all the functional stuff that you have. The functional router is from him. I only adapted it to Kotlin with nice DSL, but I'm using the building blocks that Ariane has created. So that's pretty promising, that seeing Ariane joining the Spring Foo project. And I think the topics that we incubate in Spring Foo, we also make the related improvements in Spring Framework, Spring Boot, and the Spring ecosystem to support more of this functional style, like the recent OpenAPI functional support. We have been collaborating with the OpenAPI support project to provide that, and that's so I think this functional way of writing Spring application, I like it as well, and I try to promote it. But at the same time, I want that everybody, all the existing applications that are running using Spring Boot annotations runs perfectly well on this native platform, and that's why we're working on that, to allow to run your application and change.
Yeah, that's great. That's great news. So moving from that part, I have another question from community related to, again, to Spring Boot, to Java and Kotlin, of course. So the question is, do you foresee any future for Spring and Kotlin native going together? Also, as Kotlin native adopter, do you feel competition? Do you see any competition with frameworks like Tor and Kotlin that fits better into Kotlin environment?
Mm-hmm. Okay, super interesting. So so it's fun because when you are writing a Spring application, an application in Kotlin, you compile it with GraalVM, you have some kind of Kotlin/Gvm/native because you are compiling, you are using the Gvm ecosystem, you are producing bytecode, and then you compile it to native with GraalVM, and that allows to go native while keeping the Gvm ecosystem. And obviously, that's why I'm investing a lot in that, and the Spring team is investing a lot in that, because Kotlin native is currently more mobile-oriented for iOS development, etc. It's going to be possible to support server application with Ktor and things like that. We are not going in that way. We prefer to obviously keep our only GVM compatibility, because that's just mandatory. And we think there is not necessarily the need to introduce, because Kotlin native is not a free lunch, it's also super slow. It's also introduced more manual memory management in order to get more compatibility with the C ecosystem. So I think GraalVM Native has proven that, at least for server side, I don't say for iOS, but for server side, I think the native way provided by GraalVM is a good way to move forward. And Kotlin is pretty fine working with that, because Kotlin provides create optimized bytecode. And something that I think maybe not everybody has realized, a big advantage of Kotlin in that world is the Kotlin compiler plugin infrastructure, because Kotlin plugin infrastructure that is used more and more. You can see recently the Kotlin serialization that we now support in Spring Frameworks 5.3. They do build time transformation to limit the amount of reflection you do at runtime. They allow, that's a very powerful programming model that's pretty useful. So the Kotlin ecosystem is natively a good fit with the GraalVM native platform, because basically those those plugins and much more will come later are a perfect fit with the GraalVM native. So I think Kotlin and GraalVM native are a very good fit, and I don't say that only because those are two of my favorite topics. It's because I really see a good fit between both, even if I can understand that for people, there is Kotlin Gvm, Kotlin native. It could be a little bit confusing. But at least on the Spring side, we are really investing on that. And the last point is that we are investing a lot on multi-platform support. So basically being able to share your domain model, your validation between the server and the front end, the mobile, etc. So that's why we support this Kotlin serialization, and I think that's something that will be very interesting in the future. And here, Kotlin native will be used for the iOS support, but yeah, not for the server side. But
Great. Yeah. Thank you for clarification on that part, and a few latest questions, because of course we don't have much time, but that's great conversation. So another question from attendees. Is there any incremental build capabilities in native image? So it's more about Graal native and incremental builds, and making faster the time that you spend on building all this stuff, because as we've seen, it takes like a lot of and much more time to build your project compared to before.
No, but there is some hope. So really, this native compilation process is not something that, at least from the feedback I got from the GraalVM team and from what I saw myself, is not something that you really can do in an incremental way. And that's an issue, and that's why I said it's really a CI/CD thing. But so I don't expect something that will make the compilation as fast as the GVM is. But we could. So first thing, when we reduce the amount of native configuration and when we reduce the amount of bytecode that is compiled, the build goes faster. So the first thing is that as soon as our support evolves, basically compilation time will drop because we have more upfront optimization. The second point is that there is nothing done yet on that field, but it could be theoretically possible to pre-compute library analysis for the GDK, but also for Spring. So that's maybe a topic where we will invest in the future. Not sure, and I'm looking forward collaborating with the GraalVM team on that. But I think the way where a lot of time is lost by reanalyzing the GVM library and reanalyzing the Spring library in the GraalVM native compilation process is really some time we could improve, we could basically remove, and we could optimize quite a lot the build time with that. So I don't expect real incremental build, because I think that's not how GraalVM native is designed, but I expect that for GDK and Spring, for example, you could have pre-compute analysis of the library. So no promise at all, there is nothing, but it's theoretically possible, and I think it's pretty promising for the future.
Great. And yeah, few last questions from my side. So we have Spring Boot 3. You say not have right now, but we will have it pretty soon, I believe, in the next year. So any ideas when we will get it? Any insight that you can share right now? I mean, you say the focus will be on support first, like first class for Graal native, for native images, but is there anything else? Like maybe you will gonna change the baselines for JDK or something else?
Yeah, so these are all ongoing discussions, and I can't share more about that. So I don't make any promise in terms of release date for Spring Boot 3. I just say that our native support will be based on it. And I think what we can expect is that if you are using Spring GraalVM Native, at some point we will switch on Spring Boot 3 and Spring Framework 6 Milestone. because basically that's how we could provide you the best quality of support. And that's also a way for us to have feedback from the community, from you, on what we provide, because we are going to work on big changes, and we want to be sure that we provide the best experience possible. So it will be, if you are using the Spring Native for GraalVM, at some point it will switch from Spring Boot 2.x to Spring Boot 3 milestones at some point, and I don't say when, because but that will be a smooth migration process. I think we will provide upgrade notes about how to do that, and that's how Spring Boot 3 GA will not pop up one day and everybody will be surprised. We are going to refine our Spring Native support in order to provide better support. Yeah, but no GDK baseline commands or no date commands yet. But we will keep you informed later.
Absolutely. All right, so let it be a surprise for all of us what's going to be a part of native image support in Spring Framework 6 and Spring Boot 3. At this point, I want to say thank you for all this interesting conversation. And Andrew, word to you.
Yeah, thanks a lot. I think it has been a very insightful session. For me specifically, I'm a OpenShift adopter, at work, and I have been looking into Knative as well. So now I'm certain that I don't need to throw away Spring Boot in my existing production application. So I will also be looking forward towards, Spring 3 release. Thanks a lot, Oleg, for, very insightful conversation as well, and engaging, Sébastien into neighbor topics, including Kotlin as well. So thank you, guys, and yeah, please join, Zoom meeting with our participants to in case they have more questions, or you can share more insights and continue the conversation. Thank you.
Bye-bye. Thanks for the questions. Bye.
Bye-bye.